All right, so this is about 7.4 and 8.5. And the method I'm going to describe will apply to anything, like whole of chapter 7 and 8. So the method is, first you ask the question, is it about one population or two populations? Next, ask the question, is it about a mean problem or a proportions problem? So if it's a mean problem, is the sigma known or sigma unknown? And obviously note that for two population, it will be like, is sigma 1, sigma 2 known or sigma 1, sigma 2 unknown? The next question you should ask, is it a chapter 7 problem or a chapter 8 problem? That means, is it a confidence interval problem or is it a testing of hypothesis problem? Uh, so, so if you ask these questions, all these problems will be easy for you. Let's get cracking. All right. So two populations have normal distributions. The first is population standard deviation 2 and second is standard deviation 3. Immediately you know it's a two population problem. And since they have already sorry, since they have already talked about uh, like population standard deviations, you know it's a mean problem, and you can see that sigma 1 and sigma 2 are known. Obviously sigma 1 is 2, sigma 2 is 3. A random sample of 16 measurements from the first population, that means N1 is 16, had a sample mean of 20. So x1 bar is 20. And similarly, you see that N2 is 9 and x2 bar is 19. So test the claim that population mean of the first population exceeds that of the second. Alright, so it's a chapter 8 problem. Alright, and hence we start with step 1, find H0 and HA. And look, since it's a two population mean problem, so it's always going to be like mu1 minus mu2 equal to something, and mu1 minus mu2 bigger than or smaller than or not equal to something. So here they're asking that is mu1 bigger than mu2 or not? That means, is mu1 minus mu2 positive or not? They're asking, test the claim that the population mean of first population exceeds that of the second, which means they're asking, is mu1 bigger than mu2? Mu1 bigger than mu2 means mu1 minus mu2 is bigger than 0. So mu and h0 will be mu1 minus mu2 is 0. Okay. Your step 2 shall be test statistic. So let me show you. So all right, so it's a chapter 8 problem. Sorry. It's a chapter 8 problem, and two sample problem, and it's for mu1, mu2. And by the way, scratch this out from your okay, so independent samples. So sigma 1, sigma 2 is known. So it's gonna be z equals this formula. So once again, it's a chapter 8 problem. So we are at chapter 8. It's a two sample problem. So we are here, and scratch out like this portion we don't need. Scratch this out. So we only need this one, and this one. And obviously we need these three also, like for one sample. So among these three that we need, it's a means problem. So that means one of these two. And we know that sigma 1, sigma 2 is known. So that means this formula. Let's calculate what it is. Okay, so that seems correct. So 0.89. I only take two digits because for z you usually take two digits. All right. Let me write this nicely. So step 2 is done. Step 1 is finding H0 and HA. Step 2 is finding test statistic. Step 3 shall be finding the rejection region. All right. So it's look at HA. HA tells you that it's a right-tailed test. So your rejection region shall be reject if Z is bigger than ZC. What's ZC? ZC is such that the right tail. So it's a right tail test. So we are looking at the right tail. So how big should be the right tail? It should be alpha big. Like how fat? Alpha fat. So the right tail is 5% fat. All right. So 5% fat. That means area to the left is 0.95. Area to the left of ZC is 0.95. So we go to the Z table. Search for 0.95. Okay, so it's between between this and this. So that means between 1.64 and 1.65. So my ZC is 1.645. All right, so if Z bigger than ZC equals 1.645, then reject H0. Reject H0 if this happens. So does it happen for me? No. 0.89 is less than 1.645. So fail to reject H naught. Okay. All right. So yeah, that's it. We are kind of done. So if you have to interpret the results, that means that if you fail to reject H naught, that means you kind of accept this. Like you don't say you accept, but you kind of do. Which means you'd say that like population mean for first population is not more than the second population.